The last section in 1.2, 1.2c, pages 34 through 39, we're looking at accurate and inaccurate measurements. So all of chapter 1.2 is about measurements, and we've gone through a lot of it, and now we're going to talk about errors in those measurements. So the big idea here is understanding and differentiating the different types of errors that can occur with your measurements. All right, on page 35, it gives you an equation. The measured value equals the true value plus bias plus random error. And what it talks about when you read through there is bathroom scale. So if you get on your bathroom scale every day and you know that that bathroom scale is 3 pounds over each day, that's bias because it's the same error happening again and again, and you know what that error is and you can adjust for that error. Okay, there's no way to reduce bias unless you fix the instrument. So unless you get a scale in your bathroom that works perfectly, you're not going to be able to reduce that biased error. Here on page 35 in the blue box, it tells you the definition: a systematic overstatement or understatement of the true value of the property that it is measuring. Okay, it depends on how good that instrument is. The next part of error, we're going to look at two different types of error. We're going to look at bias, and we're going to look at random error. The book talks about random error when it talks about reliability. Okay, reliability says if random errors are small, then the measurement is reliable. And the author of this book talks about, when it's talking about the bias, about a scale being over 3 pounds every day, he goes back and he says, and sometimes it gets stuck and it's 1 pound over, a half a pound over, a little tiny bit over or under every day, and that's going to be a random error, and it's still reliable if that error is very small. All right, so random error is something, I'm going to have you guys watch another video after this where they really explain bias and random error a lot better than this book, I think, does. But just to get the gist of what this book is saying with the random error is that if you do not expect that, if it's something that is different every time, and if it's little, it can still be reliable. Then the book goes on to talk about, on the bottom of page 35, while we're talking about reliability, it says, don't confuse reliability with validity just because both look and sound like good qualities. Using a scale to measure weight is valid even if that scale is not reliable. So if the random error is way more or way less than you can reasonably say would make it reliable, that doesn't mean that a scale is not a valid way to use that measurement. It's saying that this particular scale is not a valid way to measure your weight, because there's just no way of knowing every day if it's going to be good or if it's going to be off or if it's going to be not off. Okay, so that's what it's talking about there. And I have it here. This is just what I underlined in the book. All right. If you take the average, so then it's saying the next part of the book is talking about how do you reduce these types of errors, right? Improving reliability and reducing bias. All right, so this is where we're going to start talking about it. I hope you have your book out while you're doing this and maybe have printed out these notes so you can look at what's happening in the book, because I'm talking about those things. So improving reliability and reducing bias. Well, like we said before, unless you fix your instrument or buy a new instrument, you're not really going to be able to fix the bias. But the good thing about bias is if you know what the bias is, you can always adjust for it. What it talks about next on the atomic clock, which is what I was showing you in the book, is it saying that we have a national atomic clock here in the United States, and there's an international atomic clock, and I think that it's in France. If you read through it, it says it's in France. And what that clock does in France is not only do they use their clock, but they use the clock of all of these other countries also, and they find the average of all of those countries' clocks. And what it talks about, the reason the book uses that example to talk about is that it talks about the average of several measurements is more reliable than a single measurement. Okay, so their clock is going to be more reliable because they take the average or the mean of all of these other clocks. So that's always a way that you can improve reliability for that. And you can read about that. It's on page 37, the atomic clock. What I would like you to do now in order to get points for this lecture is not only do I have at the bottom of the YouTube page under the description the link to these notes that you can print off and use if you want. I also have a link to another video where he does a really good job of explaining random errors and bias errors. And instead of using the word bias, he uses the word systematic errors, which is right here in the definition of this book. So they're just explaining it a little different, okay, systematic. And what I want you to do is watch that video, and then your comment to get you credit for this lecture is to state one of the systematic errors or the biased errors that he talks about in the video, and one of the random errors that he talks about in the video. And I really hope you watch the entire video and just don't look for those two things, because he really does a great job of explaining differently than I do and differently than this book does, the difference between these errors. And even if you think you really have a good grip on it now, when we do those practice questions, the book does a really good job of trying to confuse you a little bit to make sure that you know exactly what the differences are. So I hope that you have enjoyed this video. Don't forget to click on the link below and put in exactly what I asked for, because that's the only way you're going to get credit. All right? And instructions are going to follow below the YouTube video.